Good everyone, welcome to Solar Valley. My name is Tochukwu, and today we'll be discussing the differences between a transformer-based inverter and a hybrid inverter. So I like to refer to this as not just a transformer-based inverter, but a conventional or traditional based or traditional transformer-based inverter. Why I say that is because there are some transformer-based inverters that have a bit of the hybrid system in it. But for the purpose of this video, we'll be discussing on the differences between the core transformer-based inverter, which is actually the most common type. I think when you come to transformer-based, the core system is accounts for about maybe 95%. Yes. So, but before we get into or we go into the core differences between these two types of inverters, I would like to run us through the components of a solar system, because by the time we go through the components of a solar system, you would better understand their functions and what led to the development of this guy right here. So in your solar system, we have the solar panels. The solar panels are connected to this, a solar charge controller. So this solar charge controller is connected to the batteries. So it is this solar charge controller that charges the batteries via energy gotten from the sunlight. The solar panels are connected to this solar charge controller. The solar charge controller is connected to the batteries. It charges the batteries. When the battery is full, this guy will stop charging. That is the job of the solar charge controller only. So it is not the inverter that charges the batteries. The work of the inverter is then to convert the current, because the solar charge controller stores energy from the sun in DC, but the appliances we use, the energy is in AC. So this inverter converts the energy from the batteries and supplies to the house or to your offices or for your use. Aside that, this inverter also charges the batteries using electricity gotten from the grid, that is the power holding company of your country, or from electricity gotten from the generator sets. So as time went on, the issue, one of the requirements was not just about having backup, because as normal, when there is a power failure, this guy triggers in and starts supplying outputs with energy stored in the battery. So as time went on, the issue was not just about having backup in case of power failure. If we are now looking at how do I even reduce that electricity bill, because with this system, if there is sunlight and there is power from the grid, this transformer-based inverter will supply the home using electricity gotten from the grid. So the sun is just wasting. Once the battery is full, it is there. It will keep on supplying till there is a power cut, and that is when it will now start supplying the home with energy stored in the battery, while this guy will now start charging and be replenishing the battery with the energy gotten from the solar panels from sunlight. So with that, you are still paying for electricity bill. You are still paying. The cost is still there. And the only way you could save when using this system is that you have to manually off the input, the AC input, so that electricity from the grid will not come into this guy. It will now force this controller to charge. So with that, but you have to be doing that manually. And if there is a way you might do it, you might, maybe you switch it off, and let's say for example you are going out, you are leaving your home, you take off the, you switch off the, what's it called, the AC input, so that this solar will be working, and then maybe the sunlight for the day was not that good, and then you come back later in the evening because the sunlight was not good and there was power throughout the day, I mean the electricity throughout the day, you discover that your battery might be half, or your battery will not be full. You get, so you might get home to a low battery just because you switched it off thinking there would be good sunlight, and at the end of the day there was no good sunlight, and then you ended up using the battery that would have served you at night. And then imagine what might happen if there is power failure at night. You'll be forced to run your generator set or wait it out till the next morning. So that is where this guy came into being. This is the hybrid inverter, and it is an intelligent system because it combines both the functionality of this core inverter and this solar charge controller. So this inverter, with this hybrid inverter, your AC input, that is the input from the grid, the input from the electricity from the grid, enters this inverter. It has an inbuilt solar charge controller. This guy, as big as it is inbuilt inside this inverter. And not just that, the way it works is that it helps you to minimize that electricity bill that we are looking at. When, for example, if there is if the load in the house is 2000 watts and the sun is just coming up and is giving maybe say only 500 watts, what this guy will do is that it will take that 500 watts from the sun and then combine it with and take the balance of 1500 watts from the grid and supply it to the house. As the sun is increasing in intensity, it will be adjusting itself and taking the shortfall from the grid till it is 100%. So if the sun increases to 1500 watts, this guy will take 1.5 from the sun and take only 500 watts from the grid and supply it to the home. And when the sun is of 100% capacity and it exceeds the requirements in the home, the load in the home, it will take the 100% from the sun, and I would even start charging the battery with the balance. So, and it's not just that, it all depends on the user setting. So you can set it that instead of taking the balance from the grid, take the balance from the battery, because and if you say that later in the day when the sun comes up, it will charge up the battery. So you can do it with this guy. So that is what made the hybrid inverter to be developed. Now don't forget, in this transformer based inverter, there are also some that have the hybrid technology, that is, they have this solar charge controller in them, but they are not that common, and then they still have the drawbacks that this transformer based inverter has. It still has that drawback. Having discussed the core differences between the transformer based inverter and the hybrid inverter, let us look at their individual advantages and disadvantages, because in as much as this guy has all the sweet promises, it still has its limitation. So let me start with this this transformer based inverter. Why it is called a transformer based inverter, I forgot to say that. It's because it has a transformer, an inbuilt a transformer inside it, and that transformer is bulky, and it has other bulky components that give it its heavy load, its heavy weight. It's quite heavy. So one of the advantages of this inverter is that it is rugged. It is, let me say, strength. It has a strength. It can take considerable loads. There's something called inductive loads. There are some appliances that you would put, not just that they draw heavy current, but then there's something called startup cost or startup power. So an appliance that draws 1000 watts, when you put it on initially, it might take as much as 3000 or maybe 5000, depends on the make or the model. So with this inverter, it can take that. Even if there is you mistakenly, because of course everybody's supposed to do a good inverter sizing before you go and do your installation. But let me say, after doing the installation, somebody mistakenly puts in something that was not factored in. Maybe you did a small size system, like this is the 2 kVA, and then somebody, aside the normal thing, you put in maybe your pressing iron and it goes above it. You see this inverter, it will be beeping and it will be tripping off, on, struggling to supply light. It will not just go bad, just like your generator set, the way you see your gen drawing and drawing. But it's not good. It can damage it in the long run, but at least it will not shut it down immediately. So that is the core advantage of this guy. I like to look at this as a big Mack truck, the old Mack truck. It can take you to anywhere. It might be slow, it's not flashy, it is heavy, but it is strong. No matter the road, it will go. This guy, it has all the modern facilities. Okay, let me not jump to that. Let me focus on this guy and finish the advantages. So aside, the ability to take heavy load, it is also rugged. When I mean by rugged is that it can take abuse. I don't mean you should, purposely start abusing it and treating it anyhow. But then it can take surge when there is an unexpected surge. It will take it. It will not just shut down. There is something called electrical noise, or it's also it can survive good well in buildings that have maybe all these electrical issues. They've done some connections here and there, and these faults are popping up here and there, and you are just concerned about the inverter having current flowing back and the likes. This guy can actually survive better in such environments because of the components that make it up. Um, Aside that, it lasts long. Yes, there are many of these types of inverters that have crossed 20 years, 30 years, and they are still working. They are still working. They are still, the weight you see there is just like your old diesel truck, Hilux. Whenever you dust it up and light it up, it works. So that are the advantages of this guy. Then the disadvantage, or rather disadvantages, is that um, it is not that efficient. Just look at the weight. This is a 2 kVA and it weighs almost 30 kg. This is Luminous 2 kVA and it weighs, I think it's 27 kg. And all these components, they draw power. And this power leads to losses. Even the transformer, in the process of converting, there is high energy loss. I think the efficiency is maybe about 85 to 90% or so. So there is energy loss in this. Then it is also costly. Yes, when you compare this to that, this guy is actually costlier. Even when you don't factor in the solar charge controller, it's actually costlier. It is also limited to the types of batteries that it can use. Currently we have the lithium batteries, and most of these old inverters, they don't have a special battery management system, BMS, that is very compatible, that is compatible with lithium batteries. So that is a major drawback of this system. But the major drawback that actually led to the development of the hybrid inverter is because of the non-hybrid technology in it. It's because it cannot really help you to save on electricity bill. Yes, you would be running as if you are as if you don't have an inverter. You will still be paying for bills. The only time you would be better off is when there is power outage, and that is when your batteries will pick up, and the solar panels up on your roof, and the controllers, that's when they will come to work. But aside that, you are just like a regular guy that does not own an external generator set. So let's take a look at the hybrid inverter. This is the hybrid inverter. It is also referred to as intelligent hybrid inverter because actually it is intelligent. To it does everything electronically, switches, takes balance. Things like I won't say a human. That's AI. That's where we are going to. So it is a high voltage system. Yes. There is no transformer unlike this. So all the stepping up and the stepping down is done electronically, and it can also take the same load that this guy can take. Aside, you just have to do your system sizing well and be extra careful to be sure that there are no mistakes here and there, because as I said, it cannot really take abuse as much as this guy. But let me not mix up. Let me go to the advantages of the hybrid system. Not just the hybrid transformerless based inverter. Because as I said earlier, there are some types of this inverter that has the solar charge controller inside. So talking about the transformerless based hybrid inverter, the core advantage is that it helps you minimize bill. It has a higher rate of return on investment. So the money that you use in setting it up, it will be quicker for you. You will quickly recover it faster than this guy here, because of course, what I said, you are saving on bills. You are just saving on bills. That's the summary. Then number two is that it is more efficient. Yes, the efficiency is about 90, maybe 97 to 99%. So there is less, energy loss in its conversion and everything it does because it is lightweight design. Yeah, you can see this is a 6.2 kVA Luxsun, 6.2 kVA, and see, do I'm throwing it. It weighs 10 kg, but this is a 2 kVA Luminous, and I can't lift it up easily from the desk. It weighs 27 kg. So this is a 6.2 kVA. It will still supply you the standard load, the operating load, about 6,000, but it's good to not to load it up to the highest maximum output. So what I'm trying to say is that the advantage is that it is light, it's not as heavy as this. Then it has advanced tech. Yes, it has advanced tech. There is Wi-Fi, there is Bluetooth, so you can monitor the performance of your system from wherever you are. You get, see the performance, and whether you are the user, you are the owner, or you are the solar company, you can see it. And there is this aesthetic appeal. You know, just imagine this being on your wall, then with your lithium. So the design and the likes, it has this aesthetic appeal. Yeah. Then it is cheaper. Yeah, it is much cheaper thanks to um, the Chinese guys. Yes, so it is much more cheaper to have and to install as compared to the transformer based inverters that is mostly produced by the Indians. This guy is cheaper to make. And of course, I've discussed the battery compatibility. It can work with a wide range of batteries, including the lithium batteries. You would, input your settings, and that is it. It has the special BMS for lithium batteries. So whether you want to use it for your dry cell, your what's it called, AGM batteries, or the flooded tubular batteries, or you want to upgrade and you want to use it for the lithium battery, yeah, okay with this type of inverters. Okay, now let's move into the cons, the disadvantages of this type of inverter, that is the transformerless based hybrid inverter. The major, I won't say major, One of the disadvantages is that it is not that rugged. Yes, you just have to be careful with it. You cannot compare it to this. This is actually stronger than this. And let's say the load and the likes, you just have to be very careful. There are limited room for errors. Then number two is that there must be adequate protection for this. You must have your proper grounding, your surge protectors, DCs, breakers, and the likes. Everything has to be in place, because if there is any unwanted current entering this guy, you'll be calling the maintenance guys. And another disadvantage of this type of inverter, aside the fact that it is yet to stand the test of time, is that although there is this saying that whatever thing that is not there cannot be broken. Yeah. So just like your modern cars packed with high techs here and there, that gives you, they tend to break down more because those techs can fail. And if it fails, it's a fault on it. Aside that, one thing you need to know about components failing is that because this inverter has this controller inside it, in the normal system, or not normal, in the conventional system rather, you feed in the panels to this, and then the output from this to the batteries. But this is inside this inverter, so you're actually feeding in the solar panels to this, and then also connecting the batteries to it. So if there is a mistake, not a mistake, if there is a fault in the solar charging system, normal for this guy, we'll just take this out if it can be repaired or if it needs to be changed. But while this one is out, this inverter is still working. It will be charging with the NEPA or PHCN or your national grid and be supplying output. But with this guy, if this thing is faulty, it can affect the system. Aside affecting the system, you need to take this entire system out for repairs. So that means zero downtime. Sorry, what did I say? Zero downtime. That means 100% downtime. You would be literally staying without electricity, no backup. So that is a major disadvantage of this type of system. You just need to have that in your mind. Then, having said that, um, plenty people will still ask, so what is the best? Which one should I go for? Which one should I actually go for? Because I think there is something I've noticed. A lot of information can lead to confusion. So people ask, which one is the best? Which one can I go for? And the truth is that this guy is gaining popularity. Yes, it is the most popular in demand right now. And then if you have a clean electrical system and you want your, quick return in your investment, you want to save on bills, I would suggest you go for this. But if you know the type of load you are running, they are heavy loads, um, and also you are more concerned about zero, should I say zero issues? Yes. This guy actually lasts very good, but if you just want you just want zero issues and the likes, I I run heavy loads. I'm not really sure if I would not make a mistake or the likes. It's good you stick to the tested and trusted formula. But then this one, this is in demand. It's actually cheaper. It is what everybody is using right now. And then, of course, everything is all good. All right, so that is all for now on these two types of system. Thank you for watching and staying tuned. If you find this video interesting, please hit the like button, and also don't forget to subscribe, as I'll be dropping many other helpful videos, not just on this, still on this type of system and the inverters, batteries, everything you need to know about your solar, how it works. And of course, if you have any question, don't forget to drop it in the comment section. I personally will be there. And if you have any videos or content that you want me to cover of course, with respect to solar, please drop your suggestions in the comment box and I'll be there. Thank you and stay tuned. Bye.